How's it going, everyone? Welcome. Emilio Gonzalez here. So let's take a look now at the Typescript Pro Essentials, particularly at this model of the union and narrowing. And as I went through the previous model to talk and look and practice what Typescript is all about, which is at the end of the day a project made by Microsoft engineers back in 2011 12 when they want to now write applications in JavaScript, and given his and her experience on their C sharp application, this is strongly typed application where they can see now the data flow and the shape of the data anytime that you call a function or you want to assign that in a variables. In other words, you can see clearly and explicitly is the shape of the data, and also is the flow of that. So now errors happen is at build time, not at runtime, which are very hard to spot on, which is exactly what happened here with the problem that I have with a particular client that I'm going to solve later. So, but the thing here is that I look at the development using just HTML, CSS, and JavaScript, and now with the TypeScript, when you have now is a TypeScript server, or on the development, you write your TypeScript code usually in an IDE, integrated developing environment, that this usually runs a TypeScript server, that any time that a file change, it will now generate the proper JavaScript output that is something the browser can understand and execute, all right, by the JavaScript engines. And you can see is the result, all right? So as I look at how to do that by using is now the TypeScript compiler, and most of the common options that this offer, like the watch mode and the configuration files as well, where it describes is, well, how is this JavaScript or TypeScript file will be processed, which is the folder structure, and what is the nuances that you want to go me in terms of the generated output, and what are the things that you want me to evaluate in these files. So for example, GSX, which are a specific syntax for TypeScript, and among other features, right? And also is to generate is a final output, okay? So all of this are part of the TypeScript compiler, and I went through how to do so. And then at the TypeScript basics, which is, all right, let's start here by looking at the three components in JavaScript. But the first is the type system, all right? So get yourself familiar about the type values that we can have in JavaScript, primitive and objects, what this represent at the end of the day, which is now are just state in your program that you can held inside of a variable and act as a container that you can share across different part of your program, okay? So by exploring is this TypeScript stuff here, all right, or the essential types, which is how you now, so first look at the function, all right, how you can now convert, how you coerce values from one type to another, and what is the result of that coercion, on how you can pass annotation to the functions parameters, as well as return a function value, the primitive, as I mentioned before, the default parameters in a function, how you now type objects in yeah, how do you type objects, and also um, um, the different nuance of doing that. So whether it's you be explicit about that when you assign that to a value, when you create a new object and you assign that to a variable, or you create your own type, all right? How you can now define is uh, inside of those objects is property. So optional properties or default values inside of your objects as well. In arrays in objects, how you can describe the two different forms in arrays in JavaScript, whether it is a record or a tuple, right? Uh, and or I mean, yeah, in an object, it's like that. So how you can define is a an object using the record type, which is a utility function. But again, how you annotate is the object types, whether it's by creating a new object and assigning it to a variable, so define there, or using the type keyword to define is the shape of that type value as an object, for example, and define the optional properties or the default properties, or also is defining is collections of values here and how you can annotate those values, and also is how you do that with functions, right? uh, in some of the corner cases, when using now the built-in index collections, like map and set, how you annotate those. Uh, and again, the convenience of Typescript is something that I'm gonna see that later. Is not only the auto completion feature, but that you can also look at the shape of the data, and those errors will happen now is at build time, not at runtime. So uh, also looking at where you want to define all of your type values or objects, for example, as a single source of truth. In some particularly use cases that are relevant in web development. First, what is a tuple and how you can define a tuple, how you can pass now optional values to a tuple, all right? And the dangers of any, and how you can use now promise or event listener, particularly here. So typing event listeners, aka how do you do that with callback, and try to now check mappings with promise with the fetch APIs, all right? Typing fetch APIs, typing JSON parsing, and typings maps, and typings set, typings event handlers, okay, typing functions, and typing object values or primitive, okay, primitive as well as objects. And with objects, how you can now define, so object types, okay, is one of them. Yeah, defining the object types in how you define is the primitive values in as a value, or array, set, map, or functions as part of the value. You can type in one of them. This is part of the core of this, and I really love about this because it's describing is all of the essential types notation that we're gonna do a lot of the time as we write now Typescript code. All right. Which is, hey, how do you do this and that and there and so on and so forth. All right. So the TLDR of this model, of these essential types and annotation, is that how do you do that is with functions. First with these primitive types, okay? So how do you do that with primitive type? How do you do that with objects? And how you now annotate that those objects when it had primitive values, or even arrays, or map, or set, or functions. How you now how you type in uh, if how you type in functions parameters, whether you pass a default value or optional values, how you define the return type, and how you also uh, do typings with map, set, event handlers. That to me was like awesome. Event handlers, fetch APIs, and also the dangers, the dangers of use any, or the controversial value of any. All right. So this is the basics of this. This is why we can summarize this as the type system, the value system. And then now take a look at the ID here, and what are the benefit of using the ID, and why do we even care about looking at that. So first, by understanding now what your ID is doing, in our case Visual Studio Code, which by default it is spin off a dev server as long as you have not Typescript extensions installed, where what it does, anytime that it detects now a file change in your folder, all right, it will now provide you some hint to that, all right, and it highlights those errors or hints, errors, as this curly or this red line, all right. You fix that error, and then the red line disappear. So that's the ID development workflow with Typescript. All right. And I also look at the importance of understanding that when you're describing is a variable or a statement, what this thing is doing, what Typescript can be used for that. All right. By looking is that if you're doing a function call, it's going to describe is the method. This is part of the anatomy of this declaration in Typescript. Okay, which again, Typescript is just a superset of JavaScript. All right, good. So this ID or this introspections of Typescript declarations. All right, this introspection in variables and declarations in Typescript is, for example, when you define now an assignment, it's gonna tell you what this assignment is doing as well as the type. All right, which is great. If you're doing a function call, it's gonna now give you some introspections about it, and also provide you some hints about where you can get this data. So far so good. So when you hovering on a particular function call, right, it's gonna give you now is where the thing comes from, and a couple example, as long as you follow now the GS docs, which when I look at that, to me it's like, okay, now I see the benefits of this. How you manually triggering autocomplete. In my case, I modify that to be enabled using command I twice, the letter I twice. Okay, so command I in my case. The Typescript approach for errors, which is quite interesting here. The Typescript approach for errors. Is looking at sometimes you can sometimes things fail at runtime, and some others it warns you about what will fail at runtime.
Let's talk about TypeScript's errors. TypeScript sometimes warns you about things which will definitely fail at runtime. Here, const a equals null, and we're calling a.toString. This will cause a JavaScript error. This will crash your entire app. Okay, so it shouldn't let you do this. And the error it shows you is a is possibly null. So the errors here are slightly different from, it's not telling you exactly what's wrong. It's kind of giving you an error in the right place and making you think, oh, I probably can't call toString on null. Right, that makes sense. So TypeScript sort of gives you the warnings that you need, but sometimes it talks in a little bit of an obtuse way and expects you to pick up the rest. Not everything, though, that it warns you about is going to fail at runtime. This object here, it's just an empty object we're declaring with obj, and then we're saying obj.foo equals hello. Now, obj.foo equals hello, that's not going to cause an error at runtime. This is perfectly fine behavior. We're going to end up with like an object that sort of looks like const obj2 equals foo hello. And this is perfectly fine. But if you think about it, would you prefer it if TypeScript didn't error this way, or that it did error this way? If it didn't error this way, then it would basically be saying, okay, you can just assign anything you want to any object at any time. And probably over the course of an entire application, this would result in probably quite a few bugs. So if you think about it, TypeScript is just really a rule set that is a bunch of different compromises. Sure, it's kind of erroring here in a situation that it wouldn't fail at runtime, but it's only doing that because it thinks on the whole this will result in you doing some safer coding. So of course the best thing that you can do here is you can say, you can actually give it a type of foo string, and this will make the error go away, but of course we'll look at this situation further down the line. Now it will try to warn you as close to the source of the problem as possible. So here we have a type of myUser, and we're saying const user is my user. My user has a property of name string. And we have given like a type here, or passed a property which is incorrect. It should be name, but in fact it's NME. And so it's saying type NME is not assignable to type myUser. Object literal may only specify known properties, but NME does not exist on type myUser. Did you mean to write name? This is on the other side of the spectrum, where TypeScript is giving us a perfect error for this exact situation, and even a suggestion on what we should write. And so of course the thing to do here is just to autocomplete your way there and say name. Fantastic. But sometimes, and you can see the error is like exactly where it needs to be, which is beautiful. But sometimes TypeScript won't give you an error in the exact spot that you need to. For instance, here we are creating a function type, and this function is a function that returns a string. And here, instead of erroring on the 1, 2, 3, which is the actual error because we're returning a number, not a string, it's giving us an error on the actual function itself. This is because functions, when you compare them together, you have to compare the whole thing, which we will look at later, but it means that you get the error further away than what you expect. Whereas we could restructure this slightly and instead give a return type to this function, and we could just say string here. And now it would give the error closer in. So TypeScript does its best. It really does try to make sure that the red line is exactly where it needs to be, but sometimes because of things that you're doing, it can't quite do that. So this is a good introduction for TypeScript errors.
This is alright. So the TLDR is that on this, so after I went through the ID and look at and how now the ID, especially with VS Code, kick off a TS server that at the end of the day it allow us is to enter into the TypeScript workflow loop. The TLDR is anytime you modify this file, so TypeScript will read that file, analyze for errors, and if there is any error, it's going to highlight with a red line in that moment. And once you fix that issue, it's going to rerun the server, and if this error was solved, you're going to remove the red line. And the type of error, or the approach, the basic TypeScript approach to error is that whether now TypeScript is not explicit about what errors can happen, whether TypeScript gives you runtime errors, whether TypeScript is not explicit about um, um, mm, mm, so whether TypeScript gives you now runtime errors or detect these runtime errors, or it prevents you from mutating an object in unexpected ways. All right. So for example, is defining is the rule of these types, and if you want to change, so update that. All right. Anytime that happens. Okay. So in other words, it's talking about now this immutability, and to be more precise, the typings the struct or the typings of those objects, the rule of those objects that must now be at runtime or before runtime. Okay. The other is that sometimes the errors are giving you exactly what needs to be done, which is great, and especially on the on misspelling errors or calling something that is not present. Another is when now the errors is not explicit about where is the source. So whether it tell you is whether it give you errors that points to the source, or errors that doesn't point directly to the source. Okay, and how you can quickly renaming in VS Code.
Let's look at another really beautiful little thing that you can use in VS Code and lots of other IDEs too, which is rename symbol. Here we have a function called filter users by ID, which takes in an ID of string. Then we filter over these users with user.id equals ID. So we're comparing this user ID and we're getting the right users based on its ID. Except that I'm having to use the phrase ID a lot here. So how would I go about renaming just this, for instance, this function parameter of ID string into user ID, or for instance, ID to filter by? So what I could do is I could do a command D here. So command D basically selects everything with that exact text in there. This isn't common to just TypeScript. This is just a VS Code thing, which I know how to use. And I can say user ID here, except for the fact that I've now changed user.userid as well, which is really annoying. What if there was a more powerful way that you could do this, which would smartly just change the things that are referenced to ID here? Well, you can. If you just right click on ID here and then say rename symbol, what it does is just opens up this little panel here. I change to user ID and bam, it's just worked. So user ID are now changed. And I can as well just change this to anything I want to. So user ID to filter by, for instance. I can go just to preview as well, just to get a little preview of what I'm doing. And I can apply it or discard it and bam, done. It's just a beautiful way to operate, and it also works across files as well. So if you have something you need to refactor, like you're working in a big project, rename symbol, so good, and it means that you can just move a lot faster.
Navigating code with go to definition.
Another really useful property of the
okay, so now after the approach of errors, we're looking is like the utilities. All right, the utilities here. So for example, is renaming in VS Code using the symbol, so selecting the symbol, navigating code to the definition by holding on to that.
TS server is you can use it to, and it's so a function here. We could just command click, I'm on a Mac, so the command click is going to work for me, on this function, and it takes me to the function definition. You see that? My cursor just went whoop and just went up. And if I command click on here, it's going to take me to the implementations of that function. So if I have my function here to my function, then if I command click up here, then it opens up a little box up here, which is all of the references of that function, and I can skip between them like this. So here's my first one, which is the actual declaration, then this one, then this one. Now this is, pretty nice actually when you're working in like a massive file. So let's say you have a 1,000-line file for some reason and you need to jump between all of the pieces. Command clicking on these things, or even just right clicking and go to definition or go to implementations or references, like this can solve a lot of problems, but it can also work across files, which is amazing. So on this little demo here, we have import hi there from dummy imports, and we can command click on hi there to instantly go to dummy imports. We can command click on this to instantly see all of the places that this is used. So there's one definition here and also a couple of definitions inside this file too. This is amazing for navigating stuff. It also works on global types too. So I can command click on this property key, for instance, and boom, I'm in now the global typings for TypeScript where this is declared. And if I close this and I just go back to the previous file, it can also take you to very mysterious places like documents up here. Ooh, some scary stuff we've never seen before, but these are the global typings for the DOM as well. So this is great for when you're navigating into, for instance, external libraries. You want to sort of debug some types, but also just for getting around your own code base. So of that function. So if I have my function here to my function, then if I command click up here, then it opens up a little box up here, which is all of the references of that function, and I can skip between them like this. So here's my first one, which is the actual declaration, then this one, then this one. Now this is, pretty nice actually when you're working in like a massive file. So let's say you have a 1,000-line file for some reason and you need to jump between all of the pieces. Command clicking on these things, or even just right clicking and go to definition or go to implementations or references, like this can solve a lot of problems, but it can also work across files, which is amazing. So on this little demo here, we have import hi there from dummy imports, and we can command click on hi there to instantly go to dummy imports. We can command click on this to instantly see all of the places that this is used. So there's one definition here and also a couple of definitions inside this file too. This is amazing for navigating stuff. It also works on global types too. So I can command click on this property key, for instance, and boom, I'm in now the global typings for TypeScript where this is declared.
So this is a great feature, this go to definition, because it's not only show you the implementation details, but when you hit that place, by clicking on that, it show you now all the places where this is being used.
Close this and I just go back to the previous file. It can also take you to very mysterious places like documents up here. Ooh, some scary stuff we've never seen before, but these are the global typings for the DOM as well. So this is great for when you're navigating into, for instance, external libraries. You want to sort of debug some types, but also just for getting around your own code base. So you can either do this by command clicking on the function itself, or by right clicking, go to definition, go to implementations, go to references. I encourage you to explore all of these possibilities in this menu too. So it's just amazing what you can do with TypeScript.
Okay, this is another feature. Go to definition to look at the implementation, and once you're there, you click on that to show you all the places where this is being used. Holy moly, bro. Okay.
Here we've got a setup for a very common problem in TypeScript. Let's say that we've taken this file or taken this piece of code from a different file and we've put it in its own module. Now what we need to do is we need to reference all of these things here that no longer have references. So we need to import them over. But there's a bunch here. So we've got session expiration time in seconds, in minutes, and in hours. And these are all coming from this file down here, dummy imports. So they're all exported, they're ready to go, we just need to import them. And we need to do it as fast as possible. So time yourself, make sure that you've ready to go, that you're hydrated. I want you to see if you can find a way to import these variables as fast as possible. There are three possible solutions, although one is very, very slow. Good luck.
Auto import. And with this auto import, what you can say is, hey, let's now to import all of this. but I do want to import all of it. Add all missing imports. Holy moly. So whether if you highlight all of this, or okay, is this is because it's gonna show you this quick fix. It's gonna show you this sub menu, bro. Okay, I am okay. Add import from dummy import, and here you're saying, hey, add all missing import. If I only do this, right? It say add all missing imports. Of course, and it's going to look at that. Fast imports, bro. Fast imports. Okay, these are features that are useful in your development.
Okay, so the first solution is obviously just to kind of like manually write each of these out. If we go autocomplete on here, we will see that we have all of the possible autocompletes here. And we can even just start typing here, and actually this will be auto-completed and add an import automatically for that thing. So we can automatically do session expiration time and grab it there. Auto-completes here and grab the one in seconds. Although it's really kind of annoying that it does this. It's sort of, if you do it from the middle of the variable here, you notice that it actually kind of screws up the rest of this line here, which is annoying. So if you want to do this in seconds like this, if I just remove that for a demo, then you actually need to take your cursor to the end of the variable, autocomplete there, and then you're ready to go. So bam and bam. So that was pretty fast, but that took quite a lot of effort, even just a lot of keystrokes here. What if there was a way that you could just import everything all at once? Well, on my Mac, you can do command full stop, and that opens up a bunch of refactors here, a bunch of quick fixes. I'm on this session expiration time here, but I think for this one I can actually be anywhere. Oh no, I can't. I have to be on this variable here. And I get add import from dummy import, add const to unresolved variable, add all missing imports, huh? Let's try that. Bam. All missing imports are now imported. You've got to be careful with this one, because if you have, let's say, this variable in another file, then it like exported from another file, then it might kind of like grab it from there instead. So you want to check what it's done afterwards. But for these, because I know that they're only coming from one spot, it's just beautiful. So add all missing imports is really, really nice. And you should be checking this kind of like these little, if I just open up those errors back again, checking this little quick fixes menu, because there's often some really nice stuff here, even just like if you're using GitHub Copilot, fix using Copilot or explain using Copilot. But add all missing imports, so good.
And then organizing import in large files.
Okay, let's go for another world record here. We have a handle page function which takes in a page, and we're checking if the page is greater than max page. And we've got max page up here, which is being imported from dummy import 2, but we're also grabbing a bunch of other stuff here. We could of course just delete these manually, but what if we're at the bottom of a 1,000-line file and we want to just prune our imports, make sure that we're not importing anything that we don't need to? Well, there is a way to do it, and it is really, really nice, and it's on a hotkey, and it's beautiful to use. Your job is to try to find it. It's the organize imports command, and just give it a go, see what happens, and I'll see you in the solution.
Again, is to get yourself familiar with that. Remove your use, delete only use imports. The idea of this is to get yourself familiar with this quick Typescript menu. Okay. With menu, Typescript menu in your editor. Okay. So what I can do here is say, hey, I want to actually get rid of all of this, remove all of this. Removing use. Oh, but it's doing that. This is organizing import in large files. It's gonna do that one by a time, at least in this environment. Okay. The other is that what if I want to now sort this alphabetically? Okay, so for example, if I'm using that, right, default color, right, default color. Okay, and if I use, for example, another import, which is this, default page, you know, how do I now sort this as expected, you know? So if I highlight all of this, will it show me that? Convert name into convert name import to namespace import. Okay, no. What if I do want to organize this? Right, to sort this. What if I want to now is exactly, this is the Typescript language basics. What if I want in this case now sorted by?
Ready for this? We can just go Shift, Alt, O, and bam, all done. What just happened there? Well, if I do something different here, if I go Command Shift P, again, I'm on a Mac, and I look for a command, this opens up the command palette in VS Code. What I can do is I can find the organize imports command and I can run that. And you can see too that it has command, sorry, it's not command, it's Shift Alt O, and then that, like if you do that key binding, it will run it for you. Or you can do it from the command line too. So that's two different options for doing organize imports. Organize imports will prune stuff that's sort of not supposed to be there, so unused variables here. It will also, I think, do a little bit of organization of your imports as well, making sure that if you're importing the same thing from two different import statements, then it will clean that up too. It's just a really lovely command to get, just like really autocomplete, just to be able to understand kind of how to clean this stuff up quickly, because doing this manually is just feels like a massive pain after you've done this a couple of times. It's just beautiful.
Organizing, importing large files. Exactly. So using is now Alt Shift O, organize. So get rid of all of the unused imports and organize them alphabetically. Okay. And quick fix refactoring.
Let's take a look at the quick fixes menu again. Here we have a func here, and this function, it has a random percentage, which is basically taking in like it's just sort of calling math.random here, and it's then making it to fixed, and it's sort of creating like a random percentage, which is nice, and then it's logging that percentage. What we want to do is we want to basically take the thing that's being produced by random percentage, this little piece of logic here, and just refactor it into its own function. You might take a look and you might just sort of like have a little poke around with the stuff that's like available in your quick fix, and you can see that maybe you might end up with something that works. So why don't you try some of these quick fix menu items, like extract to in a function, in arrow function, for instance, and just try out what's available, and then we'll see if you found the right solution afterwards. Good luck.
Two. So get rid of unused Typescript imports. Okay, get rid of unused Typescript imports. Right, get rid of unused Typescript import and organize imports alphabetically. Holy moly, bro. Okay, again, this is now interesting stuff here. in quick fix refactoring. Quick fix, quick fix refactoring. Use the Typescript ID menu when you need to this is it, man. It's a helpful keyword here. Exactly. Okay. Okay. So all of these are done, right? And here you can extract now some piece of computation, for example, here into its own. Well, at least this doesn't work here, but it will work on my ID. That's interesting. Is key cast. It's a TypeScript quick fix menu. Quick fix menu, bro.
So let's give this a go. Now, it's really important what you target with your quick fix. If you target random percentage here, you're going to get some different options. You've got inline variable here. Let's try this out. Well, what that does is instead of using just logging the random percentage here, it actually just removes the name completely and takes this and just inlines it into the console log. Let's try that again. Inline variable, bam. Very nice. Notice how fast it did that as well. I just love this stuff. Okay, cool. What if we do, let's say, just grab this little bit here, and again, using command dot, we can say fix using Copilot, explain using Copilot, extract to constants in enclosing scope. Let's try that. Ooh, we got new local. Okay, so So let's give this a go. Now, it's really important what you target with your quick fix. If you target random percentage here, you're going to get some different options. You've got inline variable here. Let's try this out. Well, what that does is instead of using just logging the random percentage here, it actually just removes the name completely and takes this and just inlines it into the console log. Let's try that again. Inline variable, bam. Very nice. Notice how fast it did that as well. I just love this stuff. Okay, cool. What if we do, let's say, just grab this little bit here, and again, using command dot, we can say fix using Copilot, explain using Copilot, extract to constants in enclosing scope. Let's try that. Ooh, we got new local. Okay, so random times 100. Let's try that. Beautiful, and we can save, and then Prettier will sort of clean everything up. That's really nice. Let's try the opposite of this, inline it again. I just love playing with this stuff. How about we actually get back to what we're supposed to be doing and taking this whole section, this whole piece of code, and just saying extract to function in module scope. If we extract it to constant in module scope, then it will do this, which is not necessarily what we want. We want it to do extract to function. And now we get to name our new function. We can say get random percentage like this, and now it all just works beautifully. So now we've got a function we can reuse in different places for get random percentage here. We can even move it to a new file if we want to. These like built-in just quick fixes are so useful, and you can really do a lot with them that I probably can't even cover in the scope of this chapter.
Okay. Autocode formatting with Prettier.
One of the greatest coding inventions known to man is Prettier. I once bought a formatting JavaScript book when I was just first learning JavaScript because I thought it would be important for me to understand, whether I should use tabs or spaces, how I should properly format a function. Now I don't need to worry about that at all because Prettier just handles it for me. If we look at some code, let's say just this code here, and I add some sort of random spaces inside here, add some more spaces. When I save my file, as you probably will have noticed so far, it just jumps back into the position it's supposed to be. I can just Command Z if I want to. I can also just do it.
This is just describing is this nice utility. This is describing is the used to the day-to-day operations. All right, the day-to-day operations using TypeScript. That's it.
Command S, whoops, that's not right, Command K and then S in order to save it in this state, but why would you? Prettier can just handle that all for me. So the way this is set up is I have a package.json in this file, and Prettier is installed there. I also have a Prettier VS Code extension installed too. And then I have one more thing which I've got set up, which is inside. I'm going to go Command-Shift-P, and I'm going to go to my user settings, and I have a setting called Format on Save. And what Format on Save does is it formats the file you're doing on save. So a formatter must be available, the file must not be saved after delay, the editor must not be shutting down. So what it means is that every time I save this file, before it commits the save to the file system, it actually just runs prettier on this file and this file only that's open. It's very, very fast. It means that your code is always looking beautiful and looking very, very clear. And I have no way of knowing how I can possibly code without it. It's just the absolute best thing I can possibly recommend for your IDE. It's not necessarily about TypeScript even. This will work in lots of different language. Prettier supports just plain JavaScript too, supports lots of other languages, but it's really fundamental to getting a good handle on how to work with TypeScript. And it's something that I don't even think about now. I just press save, formats for me, it's beautiful.
Ahí va. Exactly. In Apple, command Shift P to open up the palette control and type for restarting the Typescript server.
Here we've got a setup for a very common problem in TypeScript. Let's say that we've taken this file from or taken this piece of code from a different, very, very slow. Good luck.
And get used to the contextual menu. Mm-hmm.
We've been talking about the TypeScript server, the TS server that runs in VS Code in glowing terms. You know, it does all of these cool things for you, gives you autocomplete, gives you rename symbol, gives you loads and loads of cool stuff. But sometimes you will need to do something not very nice to it. Sometimes you'll need to reset it. This can happen when like configurations change in TS and it's not quite doing what you think it's doing. Sometimes it gets out of sync in funny ways because it doesn't notice that a file changed, for instance, when it's git ignored. And resetting the TS server is always really good to have in your back pocket just in case. So we will look at examples of when we might need to use it later on. So I will just give it to you now as a way that you know you can do it just at any time. So if you ever think that TypeScript's doing some weird stuff or being maybe a little bit slow, what you can do is you can go Command-Shift-P and we can go restart TypeScript server. There it is. We can restart the ESLint server if you've got the ESLint thing, but it's TypeScript that we really care about. This will take just a couple of seconds to happen, and then it just kicks into gear again. No fanfare or anything, it just restarts, and then it means that it can sort of relook at your files and make sure the errors you're seeing are correct. So there you go, restarting the TypeScript server.
Yeah, but this is additional. This is the tool in the day-to-day operations. That's what is you. That's what Matt Pockup is mentioning here. Is the day-to-day tools for our operations. So not only that, make your be aware of the ID. In our case, VS Code, and using our TypeScript, what the thing is doing when you kick off your ID, all right, and understanding now these introspection topics, using now the quick fix menu, introspection of your variable and statements, all right. Also, this introspection in your variables and statement. Also, how you can get some piece of information about when you're hovering on method and functions call. How you can now annotate some documentations on your hover. How you can now exactly, and then is when it comes to this day-to-day operations, manually autocomplete or triggering manually autocomplete. What this tries autocomplete or quick fix help you to do? What are the TypeScript approach to errors, whether it is a runtime errors or errors that it needs to be follow the rules of these static notations, or sometimes the error might point you to the source of the problem, and sometimes not that clear. And speaking of this error, is that how you can use this, for example, for enabling fast auto imports. How you can also organize your imports alphabetically. How to trigger this. How to trigger this auto imports, fast imports. So organize your imports. The quick fix refactoring by selecting a target or by highlighting a text, and then provide you some suggestions about it. And then out of formatting your code, and how useful it is for us to restart the dev server. And finally, all right, let's get into the weeds here, which is unions and narrowings. All right, okay, I'll be right back. All right, so now finally let's get into the weeds on the union and narrowing, shall we? Let's make this things a little bit here. And there you go. All right. Handling null values in TypeScript. This is a very interesting topic because at the company that I'm currently working at, they have this null stuff happening in their database at the database layer where they have like like a month, you know, they have like a month trying to solve a specific problem here of this null here. So okay, the TLDR is that looking at unions and narrowing, all right, or values.
In this exercise, we have a function called getUsername, and we're passing in getUsername. And what we're doing here is if the username is not equal to null, we return user username. Otherwise, we just return guest. Now down the bottom here, we are expecting to be able to call getUsername either with a string or with null. And this is currently not working. We're getting an error here saying argument of type null is not assignable to parameter of type string. Now, you can imagine, like, we would probably never actually call this with a null value here, but let's imagine it's like a property of a user that we're getting from the database. Well, they might have a name or they might not, depending on how they signed up. So we need to be able to handle nulls here. But currently, this declaration of username only handles string. So this sort of check of null is sort of not really doing anything. We need to change this definition, the username definition, to be string or null. Good luck.
Well, in this exercise is just to change that to say, hi, this is string or null. So this is the type annotation here, right? And it's interesting because also you are now using some of this type annotations utility functions, okay? That you can think of this like a like functions that instead of generating value, it generates now types, right? So here what you're saying is that, hey, the type of this identifier, in okay, this must be is a string, all right, and that must be equal to do so, right? So that's why it's using now the equal here to actually verify that the type of this identifier is this specific value. And not only that, once you evaluate this, you expect this. You have another one to say, hey, this must be true. So that's why here, so when you don't and this is quite interesting because you can use this to debug even your own code, a test, right? Right. Right. So this is how you can start to use now these unions and narrowings. Again, part of the type annotations. If you look at this, at the solution.
Okay, in order to do this, we're going to introduce a whole new character that we've not used before and a whole new concept. This is a union type. You create one of these little vertical bars after string, and then this basically operates like an OR character, saying either string or null. So this means then that whatever we pass in here has to be either a string or it has to be null. This OR operator is core to how the OR is core. Oh, nice. Is core to how a lot of TypeScript magic works, really, because we need to be able to represent different possibilities in our system. Because here we can see that getUsername, now getUsername, if we hover over getUsername here, or the username variable inside there, then it's typed as string or null. But magically, once we've checked that it's not null, we can see that if we hover over username inside the template literal there, it's actually typed as string. Fascinating. We will explore the ramifications of this later. But it means, of course, if we hover over getUsername now, we can see that username can either be called with string, or it can be called with null, or it can be called with a type that's string or null, which is kind of the thing that we're getting back from our database.
That's why we are looking at narrowing. This is it. This is it. This is it, right? Mm. So we need to represent these different types of values here in our systems. So that's what we're looking at, the unions and narrowings. Mm-hmm. Okay. Mm-hmm. Mm-hmm. So here we're looking at handling null values in Typescript. But again, I do want to look at the spec here. Uh, and exploring in here, right? Narrowing. We want to represent different type of values in our system. So whether it's we unite, or we merge with others, or we narrow down. So we cherry picking some from others. So here we're looking at that the narrowing type of type guards. All right. Again, this is not nothing too fancy or out of or wild, because at the end of the day, what it's doing this is just to identify is the type of value that we can have in Java that we have in JavaScript, right? Um, so this is the type of guards, right? And then you have the truthiness narrowing using is now with, for example, here. Okay, truthiness narrowing. You gotta be careful with this. You gotta be definitely careful with this. All right. Because now it enters into this condition or this control statement, or how now a specific statement that is coercing those values. Uh, for example, like if and some looping iteration like do and while. Okay. Okay. Makes a lot of sense. Keep in mind through that truthiness checking on primitives can often be error prone. Don't do this, keep reading. Alright? In fact, you just define is values here. If the value is not values, so in other words, it's in this. If you're receiving a string and then you check if that string is as an object, then you do this, or if you do that, we wrap the entire body of the function in a truthy check. But this has a subtle downside. We may no longer be handling the empty string case correctly. Typescript doesn't hurt us here at all. But this behavior is worth noting if you're less familiar with JavaScript. TypeScript can often help you catch bugs early on, but if you choose to do nothing with a value, there is only so much that it can do without being overly prescriptive. If you want, you can make sure you handle situations like this with a linter. One last word on narrowing by truthiness is that Boolean negations with this filters out from the negated branches. Alright, so you got things like this. Equality narrowing. TypeScript also use switch statements and equality checks like this or this. Okay, equality narrowing. Exactly. So if that has several of them, so you might narrow that so it might narrow that, right? So if they have the same case, so we can call now the string method on X and G. Otherwise, well, you're gonna do whatever you is to handle those edge cases. Equality narrowing. And the in operator narrowing. Okay. If you find this property with this name in this object, animal, so return now this. And the instance of, hey, is this object that I'm receiving is it is prototype change is it is prototype change reference have a reference to this object that contains all of this property the properties. So all right. Mm-hmm. And assignment is another way how you can narrow in here based on the computation here. Based on the computation. Based on the computation here. Control flow analysis. If the type padding is equal to number, you want to run this. Or another example like this, using type predicates. Using type predicates. Using type predicates. Using type predicates. Like exactly as fish. So hey, I'm sure that if you return a pet that is a fish, then now check for the swim property if that exists. And give it to me. If that exists, and evaluate this expression, all right? And if that exists, return true. Pet is fish in our type predicate in this example, and predicate takes a form. But again, all of this is just to now represent different combination of our type values in our systems. Using type predicates. Okay, I am quite familiar with this type predicates. And the other is assertion and function, and discriminated unions. Discriminated union, but this is more like to describe a series of possible values. Discriminating unions in your shape, that it can be either or circle or square, not a rect, and strict null checks here. It's possible undefined. And the never type on exhaustiveness checking. More on functions. Okay, narrowing. Okay.
Diving into unions a little bit more, I want to introduce this graph, which was going to come up a lot when we talk about unions and assignability. You can think that, imagine if we have a type like at the top here, where we have string or number there. String or number, it could either receive string or it could receive number. But if you think about it, you can't pass string or number into a function that's just expecting string. So this idea of being able to assign, you can assign string to string or number, you can assign number to string or number, but you can't go the other way around, is really important in TypeScript. And as we work through these exercises, I'm going to expand out this graph with all of the types that belong in TypeScript, so we can get a sense for the shape of how TypeScript understands assignability. Very important. In this exercise, we have a move function that takes in a direction, which is typed as string, and a distance, which is typed as number. The idea here is we could move up by 10 pixels or move left by 5 pixels, for instance. But we're actually expecting only a certain set of strings here. We're not expecting you to be able to call it with up, right. Really, the directions that we want are up, left, down, or right. And we want to make sure really that only those are available, and ideally that they would be auto-completable as well. So people using the function could see what types you could pass it. So that's your job, is to try to find a way to type this direction parameter as something that makes sense in this context, you will need to use a literal type, which we've not seen before, and a union type, or rather mash them together and combine them. Good luck.
Yeah, they call this literal, but at the end of the day, it's part of the narrowing here. It's part of the narrowing. Everyday types, right? Union type and aliases, interface, type assertions, and this kind of stuff. But again, it's most of the time is this. Is the union type, defining a union type, working with union type aliases. And let's get into this. So in other words, you're expecting here is direction and distance, right? So what I can say here, right, is something like, no, we have to be like this. So what I can say here is, this direction, I expect this to be is either up, or exactly being literal, up, left, right, up, left, right, and down, and down here. All right, but this is now passing is literal types. Okay, similar as there are literal values. Now here we have is literal types. Okay.
Okay, so the way that we do this is instead of having a strings is what we care about here. So now we have up, down, left, and right as the possibilities. And now you could do some logic with up or down or left or right, because we could check if direction equals, and we get autocomplete on the options here, which is so nice. We also get autocomplete when we're passing in our arguments. So we can move up, we can move right, we can move down. Oh, it's just so nice. And of course we get errors here by saying argument of type upright is not assignable to this parameter. Very, very cool. Now we can, of course, just take this and we can extract to a type alias and we can say direction up here. And now this means that our move function, first of all, the errors get a little bit cleaner actually, because instead of having it sort of spill out all of the union types, we actually just says direction, which is really nice. And instead of having it hover over and it show us, up, down, left or right, we just still get direction there. But of course we still get our beautiful autocomplete. So this is really, really nice. We can capture union types and unions of literals in a type and use it later. And we can also do this, also just have it in line. That's perfectly fine too. It doesn't make too much difference. But this is a really nice introduction to literal types, so literal values in TypeScript, and using them with union types. And this is just fabulous. Let's look again at our assignability graph here. We now have a bit more complexity. There's now 3 levels, where we have this up, down, left, right one in the center here. And this is basically consisting of each of these ones down the bottom, so up, down, left, and right. And finally, those are also assignable to string. You can think of this in the other way around, of course. String is not assignable to up or down or left and right because it's too wide. And each of these, like up or down or left or right, is not assignable to the ones below it either. So you could think of these as kind of, we're getting a sense of like sort of topmost types, like the wider types in TypeScript's ecosystem, and the bottom types, so the ones that are lower in the sort of assignability system. You can of course imagine this too, where if we had a union of let's say left or right, then it would be assignable to up or down or left or right, because either of those possibilities can merge into that one. So there we go. This is how literals work in terms of thinking about wideness and narrowness in TypeScript types.
Wideness and narrowness in TypeScript type, especially when you assigned a type to, when you assign a type to. wideness and narrowness. Exactly. So you want to get the general value types, and then do a specific types of it. So for example, here,
In
like
this exercise, we have a few different functions here. We have a handle error case function, which takes in a code which is currently typed as string. And then we have a handle success case function, which takes in a code currently typed as string. And we have HTTP code at the top, which is a union of a bunch of different codes, a bunch of 400 codes and 500 codes, and then there's some 200 codes there too. In REST, which is what this is kind of mimicking, 200 codes are considered success cases, and 400 and 500 codes are considered error cases. So what we want to do is we kind of want to split this up into two or a few different types here. Because our error case, we want it to handle just the error cases, and our success case, we just want it to handle the success cases. You can see inside the tests, inside the functions, it's expecting code to equal 400s or the 500s, and in the success case, it's expecting code to equal 200s just there. So your job is to try to find a way of changing this type so that we can have maybe several type aliases that all correspond to each one without having too much duplication. Ideally, we don't want sort of multiple of 400 in there because the handle all case is working perfectly well, but it's just the handle error case and handle success case that are currently breaking. So the main little puzzle here is working out how to combine different unions together, and I'll leave that one with you. Good luck.
So in this case, is by saying, or you create now, but this is the HTTP code, right? So you say is only select one of them, all right? If you hover here, right, to see what is this suggestion, or in other words, I'm going to combining, yeah, so combining union problems by doing this, all right, and this thing is expecting this, right? And what you can do is extract to type aliases, and look at this. It say, hey, but in my case, I don't want to do this. So whether if I say, hey, I only want to get is the from the HTTP code, I only want to get a specific ones, right? Yeah, I do want to get is a specific ones, right? So that's the question. So how can I select a specific one, or say omit, because this is another one, all right? I can say take this omit, all right? If I read about this, it requires 2 arguments, right? And the key that you want to extend for. Okay, so I want to omit is in here is code. This is handle error case 200 or 201 or 204, right? So omit those cases from here, right? And here is gonna say, hey, is this actually the proper code? To infer the type of a runtime construct, right? So that's what we are doing is in this particular case. So if we put this, for example, something like here, right, and we say this one, for example, type false does not satisfy the constraint true, all right? So omit is, so I want to get this one, for example, or I can use now the other one here and to include as well the code that actually I don't want to get. Say omit is all of these error cases, right? So now TypeScript saying, hey, type false does not satisfy the constraint true. Okay, so in other words, it means that this code here, right, is not satisfying is this parameter of the omit code. If I take a look at the view problems, you say that this is not true. So what I do want to do is, hey, it is possible for me to get only those values here. So omit this. All right, so if I go here to this and say, hey, let me omit this, right? Okay, but this is for, what does it work for? Exclude. Okay. Okay. Omit is for objects, and exclude, okay, that's interesting, and exclude is for union types. So when I say, hey, I want to exclude, all right, here, and the same for this, but again, this is a specific type utility here that works for union type, right? That's it. All right, so extract the type or the exclude. You can say, hey, exclude this set of values and only get me this one. So now I do have is a different shape of the data here. So instead of using now omit, I say exclude from that, right? So exclude this part of the code. Okay, exclude this code here. And now this worked as intended. And the same for this. That's interesting. It's getting familiar with these utility types. Again, all of this is just to have the ability to create new type values in our system. Okay. Why? When? For example, well, anytime that you need to, for example, manage global states, or reading or writing local values, right? In your local store, fetching data from the database with these new changes, whether it's they remove some properties or they add new or exclude some values in the union type.
So let's figure this out. This HTTP code, we kind of need to split it into a couple of different types. Let's take all of the error types and let's go type error code equals all of these. So now we've got our error code, and this is going to be our success code down here. And now our error case and our success case are going to be pretty easy to type. We can replace this with error code and replace this with success code. But how about our HTTP code down the bottom? We can say type HTTP code. And how should we do this? Well, we can say
is now the error code and the success
error code or success code. So this means it's just combining those two unions together. So now HTTP code can either, God, I'm having a real trouble saying that. It can either be 400 or 201 or 404 or 204. And this means then that it corresponds to this type down there, which means that, or this type check, which has all the 200 and 400s in it, and it works. So this is a really nice way of thinking about unions that you can later combine them together and make these beautiful combinations.
Oh, right. In other words, I went through this exercise with this combination. All right. So I use now is this utility function to say, hey, let me actually get each one of this, right? That might works. That indeed works. That indeed works. All right. That indeed works. That indeed works. Here. Hmm. Okay, and the idea is to get a sense of, for you to say type error code, okay, and then you got all of this error code, right? So the or the yeah the approach for this and the success code, right? But the idea here is, and whether you combine is the success code with the error code, okay? So it's like you merge them, and here you call is your specific. This is an error code, and the other is the success code, right? But the whole idea of this is that how useful is for us to having small subset of types, and then you can combine into one bigger one, right? So this is like the intuition here. It's like how do you have these different types annotations, and how you can use them to combine bigger ones or more general, more wide types.
How big can a union get in TypeScript? Well, we've got this alphabet type, which is basically a massive union type of all of the letters in the alphabet, so 26 in there. And we've got a type down the bottom here, which is too big. This is using some advanced type syntax to basically create what it's trying to do is it's creating a string where each of the letters in the alphabet can potentially be in each slot here. So it's like 4 letters long, each of the ones of the alphabet. And you might think TypeScript will probably be able to handle this. Well, if you think about it, it's like 26 here, times 26, times 26, times 26. So 26 to the power of 4, and that creates a union type that is too complex to represent. So TypeScript sometimes just sort of like goes, oh, please don't make me do this. Why are you making me do this? Because usually a better way to just represent this is just with a string. You don't need to be too precise here. And so there is an upper limit on how big a union can be in TypeScript, and you'll sometimes hit this error. But usually only when you're doing something that you probably shouldn't be doing. Anyway, I thought I'd include this because it's pretty fun.
Interesting. Again, exactly. You're doing all of these possible combinations that this data type can be, and TypeScript will say, okay, this is too much. Let's gonna use a genetic primitive.
Let's talk a little bit about how literal types resolve with wider types. You can see here that we have a getResolvedIconSize function, which is taking in an icon size parameter of either small, medium, large, or string. This means that if you pass in small, it's going to return 16, that will return 32 if it's medium, or return 48 if it's large. Otherwise, it just returns the icon size. Now, you would think, okay, we've got our icon size here. It means that we can, pass in each of these. But let's think about the assignability chart that we saw earlier. Here we
the
think, okay, we've
assignability chart of this. So if you pass size, it can be either 1, 2, 3, or this huge possibility.
Icon size here. It means that we can, pass in each of these. But let's think about the assignability chart that we saw earlier. Here we've got small, medium, large, or string at the top here. And if you think about it, string is assignable to that, so is small, medium, or large. And so if you think about it, everything inside this top area here can just be represented by string. And this means then that if we take a look, basically all of the actual literals, when they're in a union with their wider type, they get cancelled out. And TypeScript sort of forgets that they exist because it doesn't need to really keep track of them. So all of these arrows of like small here, really because they're assignable to string, then this whole thing at the top here just counts as a string. And we can see this in action here. So get resolved icon size here, even though it's got all of this sort of stuff when you hover over it, which is quite useful, it won't give you autocomplete for small, medium or large here, which is a little bit annoying if you think about it. There is a way around this, which is a famous incantation that TypeScript wizards know about, so I will teach it to you here, which is if you wrap this in some parentheses, give it an and sign, and then give it this empty object shape, for some reason it just starts working. So now you get small, medium or large in this particular slot. That's a fun little trick, but not one that I would introduce to, let's say, an application code base without some previous thought. And we will look at this syntax and what it does later, but I thought I'd just throw it in here just for a little.
Okay, you're telling to Typescript is, hey, this can be also in a string and an object, and the interception of the object. And the interception of the object. So remember, is combining is type here. So what is intersection between a string and an object here?
A little bit of wizardry sprinkled in. But the main idea here is that you shouldn't think about literals and wider types in a union together in a way where you think, okay, it's either this or this or this. Really, all of these just get subsumed into string, and so you might as well just be typing string in these situations.
Resolving literal type with wider types. Okay. So the intuition here is
now that we know about union types, it's time to introduce one of TypeScript's most powerful features, and that's narrowing. So here we have a convert time function, and the convert time function takes in a parameter of time, which is string or number, and we have an if statement here. The if statement checks if type of time is string, and if it is, then it console logs it, but you can imagine something else happening in here. If it's not type of string, then it still console logs it, and then it console logs it one more time. And if you think about this, if we call it with number, then this is going to resolve to false, which means inside this little bracket here, this little scope, TypeScript knows that this is never going to be a number, right? Inside there is never going to be a number. So if we hover over that, it's typed as string. TypeScript knows too that if this resolves to be true, this kind of type of time equals string, if that resolves to be true, then in the else clause it's going to be false. So that means that it's going to be number instead. And then right at the end of this, because we're not like returning or doing anything inside here, then this time at the end is going to be still string or number because we're outside of this sort of narrowing scope.
This is part of the
So you can
narrowing
think
here.
of here as these scopes as being really important in TypeScript when it comes to narrowing things down. If we add something else to this union, let's say we add a boolean there, for instance, now time is going to be still string, right? Because it's still checking if type of time equals string, but inside here it's going to be number or boolean. If we add in an else if and say type of time equals number, for instance, then it will be checked there and it will be number. Otherwise, we'll go else, console log time again, and now time is going to be boolean. Isn't this so powerful? And aren't your brain cells just sort of sparking with all the cool things you can do here? Type of is just one way that you can narrow down unions and narrow down all the different possibilities.
Yeah,
and we're going to be looking at a bunch of different ways in the remainder of this section. In this exercise, we have a couple of things going wrong. We have a validate username function here where we can pass in either string or null, and it's going to always return boolean. We've added a return type to make sure it does. Now, what we can see is in the tests here, If we pass in some strings here, then it should basically check to see if the username length is more than 5. And if it is, then like with Matt1234, then it should return true. But Alice, because it's 5 or less, it should be false. And Bob, because it's less than 5, it should also be false. But how about for if it's null? What if we pass in null there? Well, this is the test that's failing. And currently we're getting a runtime error because we're passing in null, but actually username here is possibly null, and we're actually causing a runtime error by trying to access a property of null. So I would like you to rewrite this function to make this error go away. I just want you to mess about with the code that's inside this block here, and you'll probably need to use some sort of if statement and do a little bit of narrowing to make it go away, to make the test pass and to make this type error go away. So good luck.
So far I have looked at the unions and the narrowing, but the union especially is to say, let me wrap this. So the intuition of union is that it's great for combining small piece of types into bigger ones, right? So it is great for having as small piece of types to create now a bigger set of types, right? So this is the utility of the union according to Matt Pocock. All right, and how useful it is for us to now get that. All right. And also, if you want to now combine his literal with, again, all of this is with strings. And if you want to combine his literal with type literals with a wide type, like string in this case, you need to do some little hack to actually get those values. Okay? So, but the whole point of this is by looking at the strings and this subset of types that you can create based on a union type, and then you can compose more bigger set of values or types. All of them now will boils down to that, right? All right, good. So here we're looking now at the narrowing, which is another powerful feature because as you might as you look, you can define as several possibilities that this the type of this value can be, for example, in a parameter, and then narrow down by checking the type and give you access to the specific methods on that. For example, in this case, the primitive values, whether it's number, string, or boolean. So you can imagine here that you can also work with is now objects. You can narrow in with instance of, and that makes a lot of sense to go with. So in our case here, it's say, hey, you are validating that can be either a string or a null. Rewrite this function to make the error go away. All right. So here you say, hey, it should return. Okay, this is the test. So it should return true for valid usernames. Expect validate username math.do. So I want you to have at least a length of validate username must be greater than 5 characters. Of course, this is false. And if you pass now null, it must be false. And here, what happened is, this expression is never being called, right? Wait, what? Okay, there you go. This expression is never being called, and what it's doing is now evaluating this statement JavaScript, and it say, hey, this username, if you have a length property, it's because it is a string. So what we can do here is this. We can either say, hey, if the username identifier, it is type of, which is going to return now a string, is equal to, and then using triple equals to verify it is type, that they have the same type, all right, of the string. So now I do want to return this, which is evaluating this expression here, right? So evaluate this expression. If it's not, right, then return now false, right? Now this is a part of the early return statement, which is a very interesting pattern that happened here when you want to evaluate things, truthy things first, and then the last case is the false case. That's a very interesting pattern here. So as you can see, that actually now worked as expected.
Okay, there are a bunch of different ways you could have gotten this right, so I'm going to go through 5 different options here. There are probably even more that I didn't think of, but the main idea here is that we want to check if username exists, and if username is a string, and if it is a string, then we basically return username.length greater than 5. Now you notice that I'm not doing a type-of check here, I'm just saying if username. Wow, very, very cool. And this means, though, that it's filtered out the null version. The issue with this one, though, is that username, we don't have a test for this, but if we said validate username sort of like empty string, then it would return false. But actually, that does correspond to the way we want our function to work, because we only want usernames that are actually have length of more than 5. So this is the first way of doing it. We could also do it by checking if type of username is a string, and if it is, then do it that way. Beautiful. Otherwise, we could also check if type of username is not a string, because if type of username is not a string, then username inside here is going to be null and we can return false, and it understands that after this early return here, where we've returned early, this username is now always guaranteed to be string. So clever. Next, we could do this. This is really quite nasty. This will...
Yeah, because if you say that this is now an object, okay, if this username is now an object, it means that, hey, whatever you're passing me here, it is of object type. In other words, it's going to coerce that this value is going to get here, all right? And if you're receiving now, if this is now an object, you say this is false.
We're relying on basically a bug in JavaScript where type of null is equal to object. And this now, type of
null is equal
username
to object.
equals object, we're checking to see if username is null in a very roundabout way. So inside here, username is null because string is not of type of object. And the final one here, we can even extract this check out into its own variable there and just say, is username okay? And do this check inside here. We can even do like a double bang username here, and this will still work because it converts it into a boolean. And this means then that you can actually combine these different checks with other ones outside of your if statements to make your code a little bit more readable. You don't have to always inline the variable there. So this is really, really nice in terms of like our options are very, very wide when it comes to narrowing. And using if statements is a really clean way that you can make your types sort of feed into your runtime logic here. Because of course, if we checked if this was a number instead, which we're allowed to do, then actually, like, is username okay is a boolean here, and username is actually typed as never. And we'll take a look at never in a bit, but it basically says that it's not what you think it is. It's not a string. So by actually having TypeScript back us up in this way, it makes our code a lot more robust.
Narrowing with booleans won't work.
There's a bit of a caveat here, which is when you're using the Boolean function, which ships kind of in JavaScript, then it doesn't quite work as expected. We noticed before that we could do this sort of double bang to make this work, where we're basically sort of converting username into a Boolean by doing this sort of like bang bang before it. Because if this one resolves to not username, and this one resolves to not username, which converts it into a Boolean and says whether it's truthy or falsy. But if we do the same thing by just applying it with a Boolean operator, it doesn't work. And that's because this is just a plain function. TypeScript is actually really good at understanding sort of operator syntax here by using or and. It understands all of those different combinations, but when you just use a plain Boolean function here, it doesn't understand it because it just thinks of this as a Boolean and doesn't understand that it's related to username. So while TypeScript's narrowing is extremely powerful, it does have little gotchas like this, which we will run into occasionally, and I'll point out as we go.
Especially with Boolean function. Gotcha, we're narrowing a map in TypeScript.
In this exercise, we're going to look at another kind of small gotcha when it comes to narrowing in TypeScript, where we have this process user map function, which takes in an event map, which is a map. And that map has a key, which is a string, and it also takes an event as the value. So this event up here has message string on it. So what we're trying to do here is we're trying to say if event map.has error, then we grab that message from the event map and then throw it. So your job here is to work out why this is failing. Why wouldn't this just work out of the box? Because we're checking up here if the event map has something with error on it. Surely it should know that event map.get error, like the map would have that error on it. So why isn't this working? Well, that's your job. And see if you can also refactor this to a way where we don't change anything about the outside of the function, but we still retain the behavior, and but TypeScript sort of narrowing works with us instead of against us. Good luck.
So especially here, so if you hover here and say, hey, this is the type that I'm taking, say, hey, event.map here has error. Okay, so it's now is checking if this is a Boolean. All right, if there is an error, so I do want to get that here and say, hey, object is possibly undefined at this moment. That's interesting. So in other words, what we can say here is whether this is the string event and map, string and an event, right? An object is possibly null here. So whether if we say this, right, whether it's by using the optional chaining, yeah, this is the optional chaining here, whether it is by using the optional chaining, which say, hey, if you find any errors when trying to access to this property, please do not throw an error. All right, instead just return undefined. Okay, in that case. So this is one way and it's interesting because now TypeScript actually figuring out that properly. So if we hover here and then I try and I use the quick fix, this doesn't actually work for me. Map doesn't narrow get map. So let me take a look at that. So map doesn't narrow map problem here. So by looking at the quick fix error here to actually kind of understand what can I do here, say, hey, move to a file or to a new file, and that's not what I want, by the way. You can say, hey, extract the constant in enclosing scope into an inner function, or extract function into a model scope. So no, that's not actually what I want to. All right. But what it says is that object is possibly undefined. Question: what is the thing that can be possible undefined here, right? So whether we add another if in our case say, hey, event map dot get error, okay, error. So if it has now an error, and if the event, exactly, if it have now an error, right, it says now, hey, somehow what you're trying to do is like, I'm going to get a possible undefined value here, but this is of the message. I'm assuming that is on the message here, right? Because it doesn't recognize that message here, right? That's what happened. So it turns out that it didn't recognize that is now a message. If you take a look at this, it's a now this function, all right, that it can now give me is the event or undefined. Okay. I can do now this. So Typescript it's saying, hey, I'm gonna get this object is possibly undefined, diggy diggy. So object is possibly undefined here, map string event. But I think that what it's trying to do, or what it's trying to tell me here, it's say, is this the object is possibly undefined. Return and specify specific element from the map object if the value is associated to the provided key in an object. Then you will get a reference to that object, and any change made to the object will effectively modify inside of the map. But again, what is telling me here is this: hey, when you call this get method with this string, with this key, I can find it or not. So in my case, what I can say is, well, so again, if you find it, all right, now give me this message here. This is the most straightforward problem that I can find here, right? And I'm going to guarantee that, hey, you get the strings or undefined, so the error hasn't been resolved, all right? But what I can do here is something like this. You receive is an empty string. If you look at this, you will always get now is an empty string. So the thing is that this method is telling me through Typescript that I can either get that value or not. Okay? And question, how you can now narrow in this? That's a good question, right? So I can even narrow this by saying is, hey, if you now on the event map you get the error value, and that give you something, all right, it means that, well, is inside of this, I want you to throw now this error. I don't need to actually check this, but it turns out that the get method still believes that, hey, is this potential here, despite that, look at this, despite that the message here is saying now this is a string. If you put this outside of that, of course it will never call that. So this is quite interesting, because if I do this, I'm telling to the message that, hey, it can be a string or undefined, all right? And if I want to narrow this, which is what I'm trying to do at the end of the day, okay, with the type event here, right, I'm trying to map this to create a map here, or to create now a record, right? a record here, or a map. So this is an interesting problem, and I know how to solve that, but this will give me is undefined or null. And in my case, I only want is the I only want is that value here, right? So what I can say is if this so if this thing that you evaluate now give you now a undefined, all right. So if this doesn't give you undefined, please give me that value. Otherwise, so I have to now set this message as it is. So now in this case, I guarantee that this will behave now as a string, and only as a string. Look at this. We're using is two operators here. We're using the optional chaining, which instead of any time that you want to have access to a property object, instead of throwing you an arrow, it gives you now undefined as value, and then you find somehow to work with that using this I don't know how this is called, operator with the French stuff. This is the operator here in JavaScript, right? The nullish operator. Okay, nullish collision, which what it's doing is that, hey, if this is now an undefined, as you can see here, view in English, right? Oh my god. There you get it here. This is now logical operators. That's right. As this nullish collision. So if the expression on the left is any kind of emptiness, null or undefined, return the value on the right. Okay, this is great because this is a great use case of using now this specific combination with map. Okay, where the idea is to narrowing this on map using using the optional chaining. Okay, so don't throw me an arrow if any of those properties are undefined. Give it to me, and this will be the default value that I'm going to assign to this. All right, that's a very common use cases. Very common use cases. So if we take a look at this, you can say something like this, right? And if you find that this is now undefined at runtime, please now use these default values here, which is now in a string. And if you can see, this actually works as expected. That's interesting.
Okay, the reason this doesn't work is because TypeScript doesn't understand the relationship between .has and .get here. It doesn't keep track on the map here what types are available on it, or what keys are available on it, or what keys aren't. If we were handling it like a normal object here, it actually would, and it would do a really good job. But we don't want to change the map, we don't want to do anything like that. So how can we refactor this code slightly to make it work better? To just hone that point more, this has function here, it just returns a boolean. TypeScript doesn't know that that boolean is related to that map in any way, and so when it tries to do the get here, it's just returning event or undefined. Ugh. So the way that I would solve this is I would first of all just extract this to a constant, and so I would just call this event, and now I can move this outside of the if statement here, and now instead of using the .has function, I can just check if event exists. And now if the event exists, we can see that like TypeScript is able to disambiguate between the event or undefined, and so inside this if statement here, and inside this scope, it's typed as event. So this is the way that I would do it, just to work a bit more closely to what TypeScript sort of wants to do in sort of figuring out the relationship between variables, instead of relying on just methods like .has and .get. Not that you can't use those, but they just get a little bit annoying with TypeScript sometimes, and it's worth knowing this gotcha.
That's another alternative. That's a very interesting alternative. I went through this solution here. If I need to go that, again, this is because I'm enforcing to have at least a default value. But sometimes you don't. You just want to go the TypeScript do its stuff. Okay, and that is, hey TypeScript, let's going to extract this into its own enclosing scope by saying event. All right, and if that event exists, okay, this is a interesting gotcha for using now map, and also we'll say for set, but again, at least for map here, at least for map here.
In this exercise, we have some code which is doing a document.getElementById app. And what this returns is a HTML element or null. So what we want to do is to make sure that app element is always defined. And we actually want to really, at runtime, make sure that element is defined. We could kind of lie to TypeScript using some techniques I'll show you in a bit, but we don't really want to lie to TypeScript. We want to make sure that by the time we're doing something to that element, for instance, let's say by this line of code down here, we want to make sure that it's definitely not null. And I'm going to leave it to you how we do that. You're going to be surprised by TypeScript's inference, I think, here. We actually want to, let's say actually we want to crash our app if app element is if app element is null, we actually just want to crash. Let's say that, and let's see how TypeScript handles that information.
So here it say, hey, it can be either the element or null, right? But I do want to guarantee that this element exists. So whether you do is something like this, all right? And again, I'm enforcing is now a different type of this, all right? Which is saying, hey, this can be element HTML elements or this, right? Or you can just say throw, right? Throw a new error here, right? You can use so throw an error here. So now this actually changed to error or HTML element, which might be the case that you want to do so. So how do I ensure the app element is defined? So by checking is now the app element, if that exists, okay, then I want to do is now this check type as it is, right? If it's not, then I want to now throw some particular error here. I want to say, hey, throw now a new error here. Say element does not exist. Okay, so this is a way of how you can now narrow in that, so you make sure that you get this type at runtime. Okay, and this is my approach. Okay, this is one way to do this, right? One particular approach to do this. You can also use now some utility functions, right? Some utility functions now infer this parameter, omit this parameter, intrinsic string manipulations, right? utility types, read-only partial awaited, read-only record pick, or extract here if you want to extract from a type literals, exclude or omit, right? Instance type or no infer, that's interesting. Model reference, iterators and generators. Again, all of this is because I do want to now narrow in this. Exactly. So discriminating unions. The never type, exhaustiness checking. All right. Type of type guards. Truthiness narrowing. Oh, exactly. Truthiness equality narrowing here. The in operator narrowing. The instance of narrowing. Assignments narrowing, which is something that you mentioned here, right? Control flow analysis, like this. Use type predicates, all right? Which is another way to say, hey, no, I'm telling you that this is the object here. All right? I'm telling you that this object will exist here. So another way to trick Java or Typescript here is not only say that, but also say, hey, it's not only applying this, or also saying, hey, as, which is type assertion here, or type narrowing, specifically the narrowing as type predicates. Exactly. So hey, I'm telling you, this is now an HTML element. So trust me, bro. It's like, hey, no, trust me, bro. You don't know what you're doing. I'm doing this. So again, this is a way of how you can tell just TypeScript to, lie about it. But I do want us to check if this actually exists, right? So again, whether is you just make sure that that element exists here, all right? By once you read this, once you read this, okay, I might want to now do something like this. So I can even create now a function here, right? Even just an arrow function here. Why is an arrow function? I'm gonna explain that later on. But here what I want to do is this. I want to run this, okay, and verify if that exists, okay. So I want to return now is the element here. So in other words, I can say is return only if the element exists, as it is the ternary condition. All right, if this is different to undefined, so please return that element. All right. I can only, instead of using this, I can say is let's do this and say, hey, let's do this, right? I do want to return if this element exists. All right. Yep, I do want to return if this element exists by saying is this, hey, if this element exists, I want to return it, right? It might be quite redundant, silly, but let's do this. say const element here. I want to hold this and then say if, right? As it is. So what I'm doing is just defining is just a simple more line of code here into this and say, hey, if the element exists, right? Well, be my guest and return the element, just like that, right? So in this case, we are actually making sure that we return this element, but it also returns undefined. You know, it's also going to return is now undefined. How can I make sure that I always get this value? You know, how can I truly make sure that I always get this value? Whether it's by using it as an annotation, all right, or by once I have that elements there, which is here, all right, I now tell Typescript, hey, I do have that. Let's say app element here. If the app element exists, so I want you to now evaluate this statement, this next line here. So whether if you use this to actually make sure that at runtime now you get the elements and then do this, or if it's not, then you want to actually is now throw a particular error as it is, right? So new error. So oh my god, the element doesn't exist, right? Just like this.
Okay, the solution I was hinting at here is that we actually want to throw an error if app element does not exist. So we've added an if statement saying if there's no app element, or if app element basically is null, throw an error, because inside this scope here, app element is null. And then you'll notice that after that, if we think of this as like an execution sequence, right? You run this first line of code. It could be null or it could be HTML elements. Then we hit this line of code, and if there's no app element, so it being null, we throw an error. This means that we can never get to this line of code here. Let's say we just console.log the app elements. We can never get to this line of code with it being null. That's just not possible. So this means that by throwing errors in these types of situations, we can just like narrow code for us in TypeScript. So this almost acts like a type annotation, because we probably know that, you know, if we're running like a VTAP or something like that, then the app elements that our entire app relies on, we might be rendering into that div, for instance. That's probably going to be there, right? That would be pretty bad if that wasn't there. But just by having this extra little element here, it means that if it, for some reason, isn't there, we'll get a proper runtime crash which tells us what's going on and alerts us pretty quickly. And it means that our TypeScript types are playing nicely. But anyway, this gives you a really nice way to sort of narrow down certain pieces of logic in certain moments. And yeah, like throwing arrows to narrow is a really, really good concept for really if you want to just manage any kind of logical flow throughout your apps.
So what I did was a complete different approach. All right, it's not wrong, but it's saying, hey, let me now verify if the app element does not exist. If this doesn't exist, so now throw an error here. Okay, so in my case, I say it's because my logic, my approach is always to verifying things here, verifying the true values, the true things. And again, it will depend. It will depend on what you want to do, and the elegance of your and the elegance of the language here to express logic and to narrow down types here. Okay. So narrowing with in statement.
In this exercise, we have a handle response function which takes in a type of an API response. Now, this syntax might look a bit confusing in the API response, but really it's a union between two different objects. We've either got this object where you can have a key of data, which is an ID of string, or we have an object which just has an error property on it, which has string. So inside here in handle response, we're basically trying to check if we're in the branch with the data attribute on it. And if we are, then we need to return the ID there. Otherwise, we want to throw an error with the response.error to make sure we're in that branch. But we've got a couple of errors showing here. The first error, we've got property data does not exist on type API response because property data does not exist on the error branch. Okay, that's kind of confusing. And this one, we've got the reverse error happening. Probably error does not exist on type API response. We've also got an unreachable code detected error here too, because we've just got an if true happening inside handle response. So this if true, then we need to change this to find the proper condition to do the narrowing here to make our tests pass, because our tests down the bottom are also not working. So that's your job, is to try to find out the right thing that you can put inside this if condition to make this all work, make it happy on the type level and make it work on the runtime.
So this is by narrowing this. So if this is true, how do you check if data is in the response, right? So you will need is to actually check that. So what I can do is something like this. I can say, hey, give me now some hints, and you won't give me. Narrowing with an if statement. Narrowing with if statement. Narrowing with in statement here, and by saying is this. So if I provide you this and say, hey, if I hover here, it says property data does not exist on type API response at this moment. So property data does not exist on type error string. How do we check if data is in the response? So whether it's by actually now doing something like this and to say response dot data, right? But you have now several merges here, and it's telling that property data does not exist on the type API response. On the type API response, and if you take a look at this, it says now you have the data and the error as it is. And when I try to access to this, is try, hey, property data does not exist on the type API. Property data does not exist on type error string. And this is interesting. You say, hey, it's trying to access to the error string. Why is that? Handle response to be 1, 2, 3, and then handle response to throw something went wrong. Okay. So again, if the response exists, which is in our case it can be is either this object or another, right? So I can now extract from this by saying, hey, if there is response dot data, right? But Typescript say no, I don't understand that. That's what it's telling you, right? Property data does not exist on the type API response at this moment, right? When this function is being called, expected with the response or the response, right? And that's quite interesting. It is API response, right? So if I'm here, say response, what is the shape of that? Oh, it seems that it doesn't. It didn't know about that, you know? It's quite confused, Typescript here, right? So Typescript right now is confused. So one way that I can say is to say, hey, let's go into the structure now. Here is the data, all right, from the response, and it say no, data is never declared because the property data does not exist on the type API response. Which is quite puzzling. So if you are not there, but I know that you're gonna be here, but based on the union type, at this point you are not telling me what this response it is. You know, there is no auto-completion feature here. Because you are now is combining different response or different types. So this combination is what drives you, is what tells me I don't know what's going on here. Please, how do I check if data is in the response? Oh my god. I'm actually passing data, but sometimes I'm passing is another one. So I know that I do need to somehow I do need to somehow verify if in data exists. All right, so if data exists, now you can have this. All right, but it say, hey, you cannot in operator to narrow a type of variable. That's interesting. In operator, you can use the in operator. Yeah, that's right. So yeah, okay. So because the shape is dynamic, okay, because at runtime you don't know what is this. It can be this or it's another one, right? And what I can say is this is, hey, let me check if this property exists in this object, in this response, and if that exists, all right, let's get into this. This is quite interesting because this is if to check for a member that belongs to that object. Instead of doing this, that's interesting. And this is something so narrow with in statement, bro. Holy fuck. That's another mind-bending stuff,
Okay,
bro.
the solution is this. You might think, oh, maybe we can change the type to make it a little bit different here. Maybe we can add like error is a string on side here. That might fix this branch. And then we could do like data is undefined or something on this branch. No, there's a much simpler way of doing this. And the way that you can do it is by, inside this if condition, saying if data in response, boom. What this does is it checks if there is a data key on the response here. And what this means then is if this resolves to true, it means that we must be in the branch where data is on here. If we had like a version of this where you could pass in data on this one, then it wouldn't actually like disambiguate anything. It wouldn't tell us anything because like data is available on both of the branches. But because data is not available on one of the branches, then it means that we get to narrow it properly here. This also makes our tests pass too. And it means that if we were throwing an error down the bottom here, then it's sort of, well actually, because of the return statement, it does manage to narrow this. But if we were operating outside of an environment where we were narrowing, we would still just get this API response. We still have both branches available. But inside this else, it understands that if it's not the one with data on, then it must be the one with error on. And so the response inside the throw new error is actually just narrowing to exactly what we want it to be too. So this is a really, really useful piece of syntax for narrowing down objects that might have different keys from each other.
Narrowing in a statement is for you want to check different subset of objects that have different properties, and you need to check if that exists.
Let's introduce a whole new type into our understanding of TypeScript. That is the unknown type. Anything is assignable to unknown. Unknown represents something that we just don't know what it is, but we want to keep type checking on it. And you can see that we can pass anything to it. We can pass hello, a number, a boolean, like an object. Anything whatsoever can be passed to unknown. And unlike any, which we've seen before, you can actually do type checking on this. We're going to look at how you can narrow this down later, but because input is of type unknown, we can't access any properties on it. We can't do anything with it. We can pass it to other functions that expect unknown, so unknown is assignable to itself, but we can't, we have to narrow it before we can do anything with it. This is really, really useful when you have things coming into your application from outside sources. So for instance, JSON that's coming from a webhook, or input from a form, let's say. Unknown is really, really useful in those situations. And unknown sits right at the top of our type hierarchy here. So we have, like, if we look at all of these values here, we've got a string down the left, so all sorts of objects here. Strings, we have literals, which are assignable to strings, number literals, which are assignable to numbers, literal booleans, etc., and null and undefined are all assignable to unknown. Unknown sits at the very top of the type hierarchy in TypeScript. It is the top type. So if you think about anything in TypeScript, that all sits under the unknown umbrella. And this is really, really useful. We're going to look at the bottom type later, but having the idea that unknown sort of sits at the top, represents everything in TypeScript is really important. And unknown is very different to any, because if we put any inside here, then we wouldn't get any type checking whatsoever. Any doesn't really sort of sit in this type hierarchy. I'll show you a diagram of it later. But really, unknown is the way that if you want to represent something that's truly unknown in JavaScript, then unknown is the way to go.
And then is dealing with unknown errors in TypeScript.
One of the most common spots you're going to see unknown in TypeScript is in these situations where you're try catching over something dangerous, let's say. So let's say you've got some dangerous code here, and this is a something dangerous function where on a 50-50 chance, it's going to throw an error saying something went wrong, otherwise it's going to return all good. Down the bottom, we're try catching over that, and in our catch clause, we have an error, and the error is typed as unknown. Okay, that's a little bit strange. This is something that happens by default in TypeScript, and what we want to do is we want to basically say, okay, when that error comes up, we want to console.error it. And we only, I think, want to do that if it contains a message attribute. So there is a really nice way you can do this. So we kind of want to find some sort of if condition here we really want to change this condition to make sure that it's acting properly, and that we only throw an error if we know it has a message attribute, because we know that errors like come with a message attribute, like this. Even this error here, if we just say like const error equals this, it will have error.message that we can then read out to the console, for instance. So your job then is to try to find a way, try to find the right condition to do this. I'm going to give you a clue. It's not necessarily, I imagine you could probably do this with like error in error, for instance, or message in error, but I want you to think of the fact that error is a class. See if that gives you a hint. Good luck.
Here. That's okay, on the instance here. So for example, here what we can say is, hey, if error is instance of the error, right? So now you can actually is narrow down this um, type in this particular part of the code to actually have access to this. Dealing with unknown error in types. That's a very clever way to work
Okay,
with that.
let's try this first one. So my first idea here, or at least the first thing I thought, was to think of if a message in error, then you can go for it. But this one, you'll notice it's sort of a little bit it's a little bit hard to wrangle. Error is of type unknown. So in fact, we'd have to go something like if type of error equals object, and do this, except now error is typed as object or null, so we need to, because of of that horrible bug in JavaScript that means that nulls are considered type of object, we probably need to also just check that it exists as well. And now finally it's sort of understanding that error.message is something that it can console log, but error message is still of type unknown here. There is a nicer way to handle this. We can actually do if instance of error, or sorry, if error instance of error, boom, everything's now working. So it's using the instance of operator, which compares whether this error variable is an instance of, and I'm pretty sure that works even if this was like a type error or something like that, because this one inherits from the original error constructor. So if it's an instance of the error constructor, then it checks it and it will console log the error. So this is something that you'll often do inside try catches. And what I tend to do is, because we're not actually like handling all of the errors here, we're just handling the ones that we know are errors. But if, for instance, someone like just threw like a string like this, then this wouldn't actually catch this boundary here. So what I like to do is just also say else throw error. And this means that you're covered both ways. So you're handling all of the errors you know about, but the ones that you don't know about, which will always come up, we're always going to screw up as programmers, they still get thrown, and so it doesn't just swallow the error and silently betray you. So this is a really nice way using instance of that you can narrow down unknown into known classes.
Especially for handling is any asynchronous stuff. Especially for handling.
In this exercise, we're going to try to push unknown to its limits just to see how far we can narrow it down. By doing this exercise, you're going to, I think, pull together all of the stuff that we understand about narrowing so far, and we're just going to push, and we're going to end up with a massive long conditional, but it's going to be worth it. You'll see. So we have a pass value function here, and this value is currently typed as unknown, and I want you to keep it that way. And if some conditional inside this little if statement, we want to return value.data.id, and if we don't manage to make this conditional, we're going to throw an error here. So your job here is, let's say we pass in data ID into here, then this result should equal string at the end of it. And this means you're going to have to do a lot of narrowing. We need to narrow down the fact that value is of type of object, that it's not null, that it has a property of data on it, that data property is an object and is not null, and then that it has an ID property which is a string. A lot of code needs to be written, and it's all going to be within this conditional. Good luck.
So particularly here, if you want to narrow down something that you don't know in advance, but you will at some point. So in other words, you say, hey, this value, so as long as this value exists, all right, and this value type of the value, if this is now an object, all right, and this value, all right, has a member ID called data, or has a member called data here, and the except the data in value, and now data okay has a member ID called data, right? In value, value data is unknown. It's a record. Value is an object and is a record, and the data is unknown. Okay, and now ID is in data here. Is in data, or is in value the data, which is a type unknown, or you can do something like this. So value the data exists, okay, does not exist on a type object. Okay, and value the data exists. Holy moly. So we have to verify if the object, if the value is not null, and if the value is an object, and if that object contains a data in value, and if that value data exists, and is the ID in value.data exists, right? Oh, because this needs to be is I need to split. I need to tell now that value.data is equal an object. Okay, is equal an object. All right. All right. Exactly, and this one, and the ID exists in value.data. Type string is not assignable to type object. Oh, because I need to check if the type of value exists, and the ID is on value that. So you have to verify couple conditions here. Okay, and also verify that the value.data.id exists. All right. The value.data.id exists, and that value.data.id type of is now an string. Interesting. So now that actually solves this. This is what happened when you don't know the object. This is when you don't know the data in advance. This is what will happen here. It makes a ton of sense, bro. It makes a ton of sense here. Absolutely, right? You have to be very explicit to Typescript about this, because that's what it is. Typescript needs to know is the shape of his data at compile time, right? So if you don't know, right, but you are sure that this is the shape of this data at that moment, all right. So far so good. This is great for actually parsing some values here, right? You say, hey, the result here, I'm not gonna give you any data here, but I do expect that this must be is this. Hey, the value must be an object, the data inside of it must be an object, and then the ID must be a string. Holy moly, bro. Narrowing unknown to a value problem. Narrowing unknown to a value problem. Like this. Holy moly. That's some mind-bending stuff, bro.
Okay, let's do it. We first of all need to know if type of value equals object. If it's an object, then we can do business with it. We know that it's probably got a data attribute. And let's next check if there's a data attribute in value here. So, okay, we've got the same error that's happening down the bottom here, but we've also got an error here saying value is possibly null. That's because we've got object here or null. It doesn't know from this check, gee, thanks JavaScript, whether value is an object or whether it's null. So we have to check it. We have to say and value even before we do this check here. So even in the check itself, TypeScript will ensure that sequentially we're not doing anything illegal. So that's good. We're now checking if it's like if it's null or not. We could even do if value not equal to null, just for clarity. And now we need to go deeper. So we know now that value is an object and it's got this attribute of record data unknown. We hover over data now, it's a type unknown. So let's start narrowing that. The unknowns are just sort of spreading out.
Exactly.
Check.
But this is useful.
Added a return type just to make sure that we're returning a string. If I remove that, you can see that currently we're returning unknown from our pass value function. So what we need to do is we need to finally check if value.data.id is a string. Let's add that. If type of value.data.id equals string. Whoa, okay. Beautiful. Now if we hover over pass value, you can see that it's a function that takes in unknown and always returns a string. Because if this check fails, we actually throw an error, meaning it doesn't resolve, and it cuts out that part of the return type. So now our checks are working beautifully, our tests should be passing as well, and it means we're home free. Now this is ugly code, right? If I was to do this in production, I would probably use a library called Zod instead, for which I've got a free tutorial on this site too. And this would be a lot simpler and just be a single line of code using Zod. But knowing that you can do this, I think, is a really nice exercise to understand that TypeScript has your back when you're doing this kind of narrowing. And unknown really is just like a massive union type of all of the possible things there are in TypeScript. And so if you know how to narrow unknown, then you're probably going to have a pretty easy job narrowing something that's a little bit clearer.
But that's why they have solutions like Zod here to handle this.
Let's talk about a type called never. We have introduced the unknown type so far, and the unknown type is like the top type in TypeScript. And if you were thinking, okay, I see what's at the top, what's at the bottom? Well, never is the bottom type in TypeScript. Never represents something that can never happen. And this means that, let's say this function here, this function, like, if we just had nothing happen inside this getNever function, then it would return, right? It would do something, and it would return void, indicating that it returns nothing, essentially. But there's got to be something stronger than that. And what happens if you throw an error inside that function? Well, now that function never returns. And so if we hover over getNever, you can see that it has a function just returning never. And this is really interesting. So never being a type that's just available in TypeScript has some really weird implications. You cannot assign anything to never. So we have a function here which has an input of never. You can't assign anything to it except for never itself. And weirdly enough, never is assignable to anything. So we have a bunch of, let's say, strings and numbers and booleans and arrays down the bottom. And this getNever function, we can assign it to anything. What? How on earth would that work? Well, let's take a look at this big old diagram here. We have the same diagram as we had before explaining unknown, except for we've added never at the bottom. And never really truly is the bottom type here. We can assign never to string if we want to these, to 1, 2, 3, to boolean, to anything. Never sits right at the bottom, and it means that anything that you have in TypeScript can never be assigned to never, because it's something that can never happen. So when you think about never, and as we sort of approach it in the next exercises, think about this diagram. Think about unknown being the thing right at the top, where you can assign anything to unknown, but you can't go the other way. And never, it's kind of like the reverse, where it sits right at the bottom. You can assign it to anything, but nothing can be assigned to it because it can never happen. Confusing, I know, but think about this hierarchy, and things in the next few exercises will feel a lot smoother.
It can be assigned to. Holy hell.
In this exercise, we have a shopping cart const here, where we have items is an empty array. We're console logging those items, and then we are pushing some things to them. We're pushing an apple and a banana to them. But we're getting an interesting error here, which is argument of type string is not assignable to parameter of type never. Your job is to work out why this error is occurring, and work out how we can perhaps add a type here to make this error go away. Good luck.
Just following the Typescript hints, it say, hey, shopping cart now is has an item, all right, that these items can be a never. What the hell? What? So this item is a never here, all right. That's interesting because I wasn't be explicit about the shape of this value. Okay, I wasn't explicit about the value. I wasn't explicit about the shape value of that key. And in this case, if I say this, right, it's a no. String only refers to a type. All right. What I can say is a string. All right. No. Wait, what? So I can say is an array of a string, right? And now the error now changed a little bit, and say, hey, push does not exist on type. So somehow it's saying, hey, this doesn't exist, right? So the array, I don't have that particular method that you mentioned. A new array here as it is. Read only prototype. Take it. That's quite interesting. You do have, in fact, because I'm being explicit about this. Okay, I'm saying, hey, I have the items here. And this must be is an array, right? If you look at the array constructor, that actually is that contain is the push methods, by the way, right? Say array, take a look, find index, fill, copy within and to local string, and the array constructor from off, and then you got the several functions. Take it. You want to look at the push method. Right, and what is it? It say, hey, I don't have any push method here. That's quite interesting. That's quite interesting. So you're right. If you are right about this, which to me is quite confusing. So if I say something like this, and then you say, hey, this is now argument of type string is not assignable to parameter of type never. It means that I need to define something like this. But again, this is if I want to say, hey, this is now a tuple here, right? But if I say now this, right, and this is now a string, right? I'm saying here is that, hey, this is the string constructor. No, it's not a string constructor, it's an array. Okay, argument of type string is not assignable to parameter of type never. That's interesting. Append the new element here. So if I am here, I don't think I'm going to receive any suggestions, which is good. If I try to view the problem here, it's not. Let me read and let me understand this. Argument of type string is not assignable to a parameter type never. Okay, so is that push receive is now a never parameter. That's interesting. Push now receive is a never parameter. Solving the never type in Typescript. So what, to say something like this, but that's not a type. I'm just trying to say, hey, this, I just want to say that this is now an array of a string, right? Just like that, and that solved my problem, you know, because I'm creating is an instance of. So now when I be explicit about this, what I'm telling to Typescript is, let me create now an instance of this array, and now this will work. That's interesting.
Okay, why is this error occurring? Argument of type string is not assignable to parameter of type never. A never has appeared inside our application. How is this possible? Well, if we hover over shoppingcart.items here, we'll see that items is actually inferred as an array of never. We'll hover over shopping cart, we can see it's an object with items, never array. Well, why is this happening? It's because we haven't given shoppingcart.items a type here, and an array that contains nothing in Typescript is considered by default a never array, right? We can technically add things to it. It's not a tuple, we can change it, but it's never containing anything. This is the type.
You know, at the end of the day, they're tripping about this because, again, JavaScript was made in 7 days, and look at the reach of that. Right.
So this is a little awkward. It means that when we then push to that items thing here, it means that, sure, we can't push string, we can't push number, can't push anything to it because nothing is assignable to never. So how do we, of course, if we did this, if we did like items, we start with a pair in there, let's say, now items will be inferred as an array of strings here. And so we'd be able to push strings to it because it would understand, okay, items is supposed to be an array of strings, we're good to go. But if we start it off empty, it's basically never. How do we do this? How do we get around it? Well, we can give it a type. So we can say this is a shopping cart type, and then say type shopping cart equals items string array here. And of course, an array with contains nothing is assignable to string array here. So we're all good. Now everything just works. This is nice. But this is another way that never can kind of sneak into your code a little bit. It's just through the empty array type, which by default in TypeScript is inferred as never array.
Holy moly. That'll be all for this video. Take care. Bye bye.